In section 5.2, we're going to talk about probability distributions and random variables. Okay, so first we need to define what a random variable is. So a random variable is a variable that has a single numerical value. So just each one has one number. And it's determined by chance. So it's something that you're doing some procedure that has some chance to it. Okay? And we represent this by x. So a probability distribution, which we normally make a table. This will normally be given as a table. Is a description that gives the probability for each value of the random variable. So our random variable will have different values, and then our probability distribution is the table that lists the probability for all of them. Okay, so we have two requirements. The first one is that each probability value, this is a rule for any probability, has to be between 0 and 1. Okay, the other requirement is that the sum, if we add up all of the probabilities, they have to equal 1. So if we're asked if something's a probability distribution, those are the two things we'll check. Okay, so here's our first example. So the procedure is you're going to choose 4 random people, and you're going to ask them what product is associated with the name Steinway. So this is kind of a brand recognition problem. Okay, so then you'd count how many of those 4 people knew the answer. Okay, so we're going to do this 20 times. You get a group of 4, you count how many knew the answer. Then you get another group of 4, you count how many of them knew the answer. So this table gives us the results. 5% of the time, 0 people knew the answer. 30% of the time, one person knew the answer, and so on. Okay, so here, P of x represents the probability that x people out of 4 knew the correct answer. Okay, so then the next question says, is the table above a probability distribution? So first we look, well, all of the probability values are between 0 and 1, so we're okay there. Then our other check is we want to add up the probability values. So we take 0.05 plus 0.30 plus 0.35 plus 0.20 plus 0.10. We'd all add them all up, and we see that we do get 1. So the answer is yes. It is a probability distribution. Okay, now, sometimes you'll have some rounding errors. So if it's something like 0.999 or 1.001, something very, very, very close, then you can count it as a probability distribution. Now, we have a mean and a standard deviation for a probability distribution. And so the mean, sometimes it's called a weighted mean. And this, kind of gives you an average value for your probability distribution. And to find this, we add up each x value times p of x value. Okay, so we take for each x value, we take x times p of x, and then we add them all up. So we multiply each x by p of x, then add them all up. And I'll tell you how to do this on your calculator as well. The standard deviation is a little more complicated, and that's why we might want to do it on our calculator. We take the square root of adding up all the x squared values times p of x. And we'd subtract the mean squared. So you'd have to find the mean first. It's kind of a longer process. Now, you can find both the mean and the standard deviation by putting all of your x values into L1. So remember, that's stat edit. So stat edit to get to L1. So you'd put all them in there. Then you would get out of that, go back to your home screen, and you would go stat, over to calc, do one variable stats. Okay, now if you've got an 84, it'll probably bring up a menu, and you'll put L1 in the first thing and L2 in the second. If you just have an 83, one variable stats will go back to the home screen, then you'll put in L1. To get to L1, you hit second and then the stat button, and that'll bring up a menu. Okay, so you choose L1, then you put in the comma, which is right above the 7, and then you put in L2, which would be in the same place you found L1. Okay, and you hit enter, and that'll give you the mean and the standard deviation. Okay, so here's another problem for us. It says, there are 5 children in one family. Let the random variable x be the number of girls in the family. So we could have anywhere between 0 girls and 5 girls. So then p of x is the probability of having x girls out of 5 children. Okay, so we've got our table here. It's given to us. It says, is this a probability distribution? So first we would look and see, are they all between 0 and 1? And they are. And then we would add up all the p of x values. So we'd take 0.0313 plus 0.156 plus 0.312 plus 0.312 plus 0.156 plus 0.0313. We would add all those up. When we add it up, we get 0.9986. And this is where there was some rounding. But since it's more than 0.99, we would say, yes, this is close enough. So, yes, this would be a probability distribution. Okay, so the next question says, what is the probability that the family will have at least one girl? So at least one means one or more. And remember, it's also the complement of no girls, right, when we talked about complements. So the probability of at least one will be equal to 1 minus the probability of no girls. So here we take 1 minus 0.0313, and we'd see there's a 0.9687, or a 96.87% chance that there'd be at least one girl out of 5. Okay, now on the next page it says, would having no girls in the family be considered a rare event? So no girls is only a 3% chance. So yes, because so it's only a 3.13% chance, and we say anything less than a 5% chance would be a rare or unusual. Okay, then it says, would having exactly 4 girls in the family be considered a rare event? And here the answer would be no, because having exactly 4 girls would be 15.6% chance. So that's not under 5%. Okay, now we want to find the mean and the standard deviation. Okay, so you want to do this on your calculator. Okay, and there'll be another video posted of how to do this. But the mean ends up being 2.5, so that means, and this should be what you would expect. Out of 5 children, you would expect about 2.5 of them to be girls. Now we know there can't be 2.5, so, 2 or 3 would be your most likely number. Okay, and then the standard deviation is 1.12, and that can be used to find things like the usual amount of girls and so forth. Okay, we have another sort of definition, but it's something you've already seen. The expected value for a probability distribution, the expected value is just the same as the mean. So if you're asked for the expected value, all you're finding is the mean. Okay, so we've got another problem here about a roulette wheel. So it says you've got a roulette wheel in Vegas. There are 38 numbers to choose from. You pay $5 and choose one number. If that number comes up, you win $175 and you keep your $5. So you walk out $175 richer than you came in. Okay, but of course if you lose, you don't get your $5 back, so you walk out $5 poorer than you came in. Okay, so it says on average, what are your expected earnings or losings each time you play? So we want to find the expected value, which is the same as the mean. Okay, so we're going to let the random variable x represent how much money you win or lose. Okay, now if your number comes up, you win $175. Now, what's the probability of this happening? The probability of it happening, since there's 38 numbers to choose from, you've only chosen one. You've got a 1 out of 38 probability. Okay, now if you lose $5, and losing we need to put a negative number, so this would be negative $5. Okay, and our probability here, well, there are 37 numbers that you didn't choose out of 38. Okay, now you could put this into your calculator to find the mean or the expected value, but since it's, only two numbers, we'll do it by hand. So we're going to take our x times our p of x, so 175 times 1 over 38 plus negative 5 times 37 over 38. Okay, and if you put that in, you end up getting negative 0.26. So what this means is on average, you lose 26 cents per game. Now, this might be a little confusing to you because you can't lose 26 cents, you can only lose $5. But an average means if you did this many, many times, if you played 100 times, then overall, your expected loss would be about 26 cents per game. So that means if you played 100 times, you would expect to lose about $26, okay, or 100 times the 26 cents. Okay, now we can also do this with kind of a more serious example instead of the roulette example. So it says a 21-year-old man just bought a 1-year, $100,000 life insurance policy for $250. So based on the U.S. National Center for Health Statistics, this 21-year-old has a 0.9985 probability that he'll still be alive after 1 year. Okay, so we want to figure out what's the expected value, okay, and what would the insurance company charge to break even, okay? So this is really something the insurance company would want to figure out because they're insuring, thousands if not millions of people, and they want to make sure they turn a profit, okay? So we're going to let the random variable be the amount of money the man, and for lack of a better term, we'll say wins or loses. Okay, so if he stays alive, he technically loses his money. And, if he dies, he may win money, even though that's not a good thing. Okay, so if he lives, the amount of money he's losing is how much he paid for his premium, $250. And so since this is losing, that's negative. Now, we know from our statistics, what we're told in our problem, that he has a 0.9985 probability of still being alive. Okay? Now, if he dies, his family, gets $100,000. Now, we want to take into account kind of the profit or how much they're making. So we need to do $100,000 minus the $250 that he spent on the policy. So they're really getting $99,750. Now, the probability of him dying would be 1 minus the 0.9985. So he'd have a 0.0015 chance of dying. Okay? So to find the expected value of this insurance policy, we would find the mean, which again, since this is small, we can do it by hand. We would take negative 250 times 0.9985 plus 99750 times 0.0015, and this gives us negative 100. Okay, so what this means is, on average, the man's losing $100. Now, he's only going to be 21 years old once, so this average doesn't mean much to him. What it really means is that the insurance company is making $100 per person on average. So on average, each customer loses $100 per policy. But where is that $100 going? It's going to the insurance company. So the insurance company gains $100. So if they only wanted to break even, they would only need to charge $150 for the policy instead of the $250. Okay, we're going to look at one more example for our probability distribution. So here we've got information about a general contractor. So it says a general contractor knows from past experience that a particular project has a 50% chance of being done on time. And if it's done on time, he earns profit of $30,000. He also knows that there's a 30% chance that the project will be 1 month late, and then his profit will only be $10,000. He also knows there's a 20% chance that the project will be finished 2 months late, and he'll lose $15,000. So we want to find out what the expected outcome is. Is he expected on average to make money per, project, or lose money? If he's expected to lose money each project, or on average, he might want to find a different business. So we need to set up our own probability distribution here. So we're going to have X, and our X will be how much money. So he makes or loses each project. Okay, and then our probability. So if it's on time, he's expected to make $30,000. And we know there's a 50% chance or 0.5 chance of that happening. If it's 1 month late, he only makes $10,000. And we know there's a 30% chance or 0.3 chance of that happening. Now, if he's 2 months late, he loses $15,000, so that's a negative $15,000. And there's a 20% chance of that happening. So the expected value is the mean. Okay, and you could either put this in your calculator. Again, it's not too bad to do by hand. So 30,000 times 0.5 plus 10,000 times 0.3 plus negative 15,000 times 0.2. And here we get $15,000. This means on average, he is expected to make $15,000 per project.